Before you try your hand at the practice problems, let's look at a problem called the birthday problem. Give us a nice walkthrough, a sort of example. So for the birthday problem, the question is, what's the probability that two people out of a given group, usually something like 20 or 25, share a common birthday? So for example, my birthday is March 6th, so since I'm going first, consider me the initial person. So out of 365 possible days, skipping leap year, my birthday was out of 365 possible days. Now, for the second person, we'd want to know what's the probability that that person would also have March 6th as their birthday. Now, it's simpler, and we'll walk through this in terms of the probability that the person would not have the same birthday as me. So, in other words, the 365 days, um, of those 365 days available, 364 would not share my birthday. So, we're focusing on the negative. So the probability that a person having a birthday other than my birthday would be 364 out of 365. Now, if we add in a third person, what's the probability that that third person does not share a birthday with me or with person two? Well, there are now 2 days to worry about. So it'll be 363 divided by 365 for that third person. Following that logic, the next person would have 362 out of 365 of not sharing a birthday, and so on and so forth, where it decreased by one every time as we added more and more people. So if we wanted to know what the probability that the first and the second person would not share a birthday, it would be that 365 divided by 365 times 364 divided by 365. So that product would be the probability that the two individuals would not share a common birthday. If we wanted to know what's the probability that three people would not share a common birthday, it would be that 365 divided by 365 for me times 364 divided by 365 for the second person times 363 divided by 365 for the third person. But now the original question was the probability that they would share a common birthday. So in that case, it's the opposite. So you can take one minus those values, the value of not sharing a birthday, to get your answer. So now it's kind of difficult to do all these by hand. So let's go to Excel and just visualize it to make it simpler. So yeah, here we have the number of people going up all the way down to a group, or all the way up to a group of 36 people. So if we have the number of unavailable birthdays here, so untaken days. At first, all 365 are available, then 364 for the second person because you subtract the first person's birthday. The third person is 363, so you're subtracting the first two people's birthdays, so on and so forth, going all the way down. So if we divide the number of untaken birthdays by the number of days in the year, we get the percentage of days that are available. So we start up here with 100%, all of the days are untaken here. And as we go down there, we have several in the 99s, 98s going down. It doesn't fall by too much though. By the time we get down to 20 people, about 95% of the days are still untaken. So that's a large proportion of the days. But if we want to get the probability of having an unshared birthday, we have to multiply these values together, like I started by talking through. So for the second person, the probability of having an unshared birthday is, highlight this so you can see, the product of these two. So for the first person, the untaken days, and the second person, the untaken days. So I use a product function so you can see here as we go down, for the third person, we have the untaken days for the first person, the second person, and the third person, and going down, so on and so forth, including all of the previous people. You see this one falls more rapidly because we have several numbers here we're multiplying that are below one. So at first, the probability isn't going to fall very much, but look, by the time we get down here to 10 people, it goes below 90%. And by the time we hit 20, we get down to below 60%. So let's think of the probability of a shared birthday. So to calculate this, I just did 1 minus the probability of an unshared birthday because those are the only two options. So even with three people, there's less than a 1% chance of sharing a birthday. But look at how the probability of a shared birthday increases. So by the time the group reaches 23 people, it goes just above 50%. So that means if you have a group of 23 people, there's about a 50% chance that two of them have the same birthday. And by the time we get up to 30 people, there's over a 70% chance that two people share the same birthday. So despite there being just 365 days in a year, in our class, there's around 30 students, depends on what section you're in. There's about a 70% chance that two people here watching these lectures in each course share a birthday.